Geometry students, get your headsets on. It's time for another session. The topic today, Mr. Mitchell here, the topic is rotation. And maybe you guys are starting to get a flavor here. We've done translation and we've done reflection. And I get the rotations. I'm going to cut right to it. Here's a rotation. I'm going to take my picture away for a second. I'm going to zoom out here. And now you see that I have a piece of paper. Rotations is my topic. It looks like this. When you rotate around a spot, a point, a center of rotation, this one happens to be counterclockwise. That's what it looks like. Let's see what it does to an image. Okay, my pre-image would be this alien in a spacesuit with no arms. He's wearing a Viking helmet. If I'm going to rotate this image, I might have directions in a homework that tell me rotate it counterclockwise 90 degrees. Here's what counterclockwise 90 degrees looks like. There we are. That's what's going to happen to my image. So yes, we have notes today, and you have a homework that is going to cover this topic that goes more in depth, especially with rules, but there's the big reveal. Okay, now if I want to take this image, I want to rotate it clockwise 180 degrees. You ready? Here it comes. There's my 90 degrees. I keep rotating it. There's my 180 degree rotation down there. Looks like he's floating in space. He's been sent out the trash compactor from the space station. I'm going to rotate it counterclockwise 270 degrees. Counterclockwise. Okay, that's against the direction of the clock. There's 90 degrees. Maybe this would help if I put this onto my coordinate plane. That's a 90-degree angle. Let's go another 90 degrees. There's 180, and here is 270 degrees. Let's rotate 180 degrees clockwise. 90 degrees, 180 degrees. Okay, so maybe the image of an alien spinning helps get the geometric principle of rotation across to you. But let's do a wardrobe change for emphasis, and let's look at an example that is a little more appropriate for your age here, taking what you guys first saw in 8th grade. And now I'm going to use some formal definitions as we look at another visual representation. Okay, so I have my pre-image, and this is not a regular polygon. It has characteristics that don't make it very symmetrical looking. I am calling it the pre-image, and I'm laying down another transparent page over here to show you we're still in the pre-image. I'm going to use some definitions, and you'll get a chance to write this in a minute. I'm going to call this a rotation a little more formally now. Our figure is turned about a fixed point. So in this case, my fixed point is the origin of the graph, 0, 0. That is the fixed point for this rotation. And this is a rigid transformation because the size of this shape never changes, only its position on a coordinate plane. So in this case, if I go 90 degrees counterclockwise, my center of rotation, nice and slow, is the origin 0, 0. Often it is the origin at 0, 0. But sometimes there is a different center of rotation. It can be any coordinate on a plane. So now I'm rotated counterclockwise 90 degrees, and you'll definitely see here that there's a mismatch in symmetry. Okay, my angle of rotation. Rays drawn from the center of rotation to a point and its image. So let's illustrate this. Here's my original point, and I'll use a straight edge. We know we rotated it 90 degrees, so I'm going to draw an arrow here. And here is my image. So from pre-image to image. Okay. And so done quickly. Now you can see the angle of rotation. If I named this P and this P prime, there is a 90-degree angle I can draw using the center of rotation as a point, as a reference, and one ray goes through point P, and the second ray goes through P prime. This is my angle of rotation. Let's pause here. I'm going to put up these definitions. So we're going to try something new here. We're going to put up some definitions and just kind of let the room catch up to that. We have visually discussed these 5 terms, and now you can get them down in your notes so you may use them as a reference. So Mr. Mitchell has taken the definitions that are in the textbook on pages you're always welcome to find as you explore your Big Ideas account. And I have boiled those down into essential statements that help me understand the terms of rotation. So to save video time, I am not going to draw these or write these out fresh. I ask your teacher to pause and then catch up for a second. And when I speak next, I will refer to this triangle in the bottom right-hand corner. Okay, these last 2 definitions here, and to the arrows, let me try to demonstrate a little bit about rotational symmetry. Here again is that definition: a rotation of 180 degrees or less that maps a figure shape on itself. Okay, so I'm using another transparent piece of paper to illustrate an equilateral triangle. All sides are the same. This one does have rotational symmetry. I'm going to rotate it here. And when will it map its figure on itself? So now it's gone to kind of the Star of David shape. And as it rotates around, now it maps on itself. So let's try that one more time. And this time I will put a little reference. Let's name this point O. Okay, so point O. Here we go. A rotation of 180 degrees or less that maps a figure shape on itself. So point O, straight north. Let's see, this would be about 90 degrees in rotation here, about there. And it keeps going. And before it gets to 180, about here, point O is mapped on top of the original triangle shape. So this has rotational symmetry. And the center of symmetry is the name for the geometric center of a figure. So its center of symmetry, for that to happen, is this point in the middle. And if I wanted to figure out how many degrees I went around, well, there's 360 degrees in a circle, and I went about 120 degrees. I went about a third of the way around the circle. There's 3 points in the triangle. So from here, there's a 90, and that's about 120 degrees where the triangle mapped on top of itself with rotational symmetry. And so now hopefully we're caught up on the opening page of your handout and what's in the Google Classroom for those of you at home. And I added one note to the bottom of the page here. Here's a more formal definition for rotation, and we have discussed these terms. Rotations are most easily confused with reflections when you're analyzing figures. Okay, so when you look at assignments, reviews, you might have to pick out what transformation has happened between an image, a pre-image, and an image. And rotations and reflections are the ones that get confused. And I hope to show you an example of that a little later. So I'm going to switch to the second page in the notes. And these are the rotation rules. We're not asking you all to memorize these the same way you would have maybe in 8th grade. But now we're getting into the technical side of a rotation. And here is an image that we demonstrated before with a practical example. If AB is my original point here, a 90-degree rotation where you can use these original coordinates and transform them to negative B comma A. There's 90-degree rotation. A 180-degree rotation takes an original coordinate and makes it negative A, negative B. And a 270 degrees, 3/4 of the way around a circle, flips the positions of your original coordinates and changes what was the X into, it changes its sign. So positive A in the X position becomes a negative A, negative version of that number, or a sign change in the Y position. And so here's that illustrated. AB becomes B comma negative A. This is very helpful. Rotations are counterclockwise unless otherwise noted. Okay, trying to be dynamic. I'm now at the bottom side of this page, that second page in the notes, and I'll run a couple of demonstrations. I think I'm going to cross out some though, so we're not going to do 2. I think you've seen the 90-degree. We are going to save these for a different kind of example, and I will show you 1 and 3 here. And let's just get a version of practicing with the rules down. If you're that student that, you make a little more sense out of using the rules of a transformation. So you've seen these guys in the homework from last week where they give you an original image. They don't give you a list of points. You have to determine those yourself. And then you're going to use a rule. Graph the image of the polygon after a rotation of the given number of degrees about the origin. Okay. So my more meticulous students have made the best use of their space. I'm going to zoom in pretty good here, right to the edge of the paper, and they give themselves a way to track the letters. Let's go in order. J, K, L, and M, 4 points. Carefully, they determine where those points are. All right. J, realize this is another graphic where they're going by 2s. So J is -2 up 4. Okay, so I'm going to fill these in for myself here. -2, 4. K I read as -5, 1, because it's just above the x-axis. L, I believe, is -2, -2. Good thing we played Battleship. And M, remembering that this is by twos, M is a 1, 1. Okay. So my 180 degrees is my rotation here. So I'm going to list these as A, B, my original. That's my pre-image. And over here, I'm going to list what happens in a 180 degree rotation. It goes to negative A, negative B. And I'll make space here next to the image. It's a sign change for each of those coordinates. That's what the negative A, negative B does. No position change for which is X and which is Y. It is a sign change. So negative 2, 4 becomes 2, negative 4, etc. 5, negative 1. Both of these change, 2, 2. And both of these change, negative 1, negative 1. Let's see if we can convince ourselves that this is accurate. There are problems in the homework today that look like this. Okay, so 2, negative 4, 2, negative 4. 5, negative 1. Boy, this is difficult to see. Oof. 4, 5, negative 1. It's here. 2, 2. Okay. Over 2, up 2. And negative 1, negative 1. It is here. That is a 180 degree rotation. The original pre-image was a square, so this should be a square. Wow. 180 degrees rotated. Let's say it went counterclockwise. It didn't tell us in the instructions, so we would assume counterclockwise. 180 degrees around. Okay. And here's the final page in the handout and in the online PDF. These four, it'd be quite a chunk to do that on these small figures. These have a rotation and then something else, or a translation first and then a rotation. So we're going to scratch these out because we're going to do one practical on the back side of this page. And I just made myself a note. We're going to use exercise 13 that is from the 4.3 homework. And the assignment is a little shorter this week so that you guys can really get your concentration on. I want to show you these last couple. There's a couple in the book that talk about rotational symmetry. We had an illustration using an equilateral triangle. The question says, determine whether the figure has rotational symmetry. If so, describe any rotations that map the figure onto itself. This one is a goofball. Now it shows me 1, 2, 3, 4. It shows me that none of these angles are the same size. There is no symmetry to this figure. Any way I fold it, there will be no symmetry. And if you rotate it, it will never map upon itself as a rotating figure, no matter where the center of rotation is. But the one on the left, yes, it has rotational symmetry. I'm going to lay another picture on top for illustration. And you can imagine maybe this is the shape of something like a playground piece when you were a kid that would spin and everybody would hold on to the middle bars so you didn't go flying off. It would have a center of rotation about there, and it would spin. And if this is, I'm going to put top so we can track it. Will it map back upon itself? Yes, it will. Every so often as it spins. So here's once from top to side, just shy of 90 degrees. Turns out to be 72 degrees. It'll map back on itself. Then it spins again. And once more before it reaches a full 180-degree rotation, it maps back upon itself. This is a regular pentagon. It has sides that are all the same size, same length, and it has angles that are all congruent. So I know that if I spin something in a circle, it's 360 degrees all the way around. There's 5 points on this shape. I just said 360 divided by 5. These are 72-degree angles. And it rotates 72 degrees about its rotational symmetry. So that's a 72-degree turn. Okay. Well, I hope this is making sense. We've been working on this for a little over a week, and you guys are probably getting used to using the rules and clicking shapes on the homeworks. We are going to flip to the back side of this page. Okay. Last piece. Turning over that page onto the back. I'm looking at exercise 13, and this is from the homework. So if you've stuck with the video this long, especially at home, you will see one of our problems worked out here. And this is what it looks like in big ideas. Graph the line segment XY, and this would work on just plain paper too, with endpoints X, -3, 1, and Y, 4, -5. All right. Graph XY with endpoints of this and that, and its image after the composition. So a composition is a combination of transformations. This one has a rotation of 270 degrees about the origin, and then a reflection in the y-axis. So I'm going to do the work on the right side, and then I will plot these points, hopefully right where they need to go, so I can get the green check mark on the left. So I'm going to write shorthand for myself. I need to rotate 270 degrees, and then reflect the y-axis. Okay, so let's kind of be methodical about this. Let's build ourselves like a little table. All right, I've got point X and point Y, and I have my original order for the coordinates. X is -3, 1. Y is 4, -5. Okay, draw yourself a vertical line. Rotate 270. Rotate 270 degrees. I check my notes, not something I have to memorize. That will take coordinate AB to B position first, -A. Okay, so it's a swap of these two positions and a change of sign for this one listed first. Okay, let's go this one. This is the second, the B, that becomes the first over here. This is the first on the left. It becomes a sign change there, 1, 3. Same down here, -5. That's the B position, becomes this one, sign change for the other, comma, -4. All right, we have done the rotation. We're done with it. So, it's almost as if we've created one of our figures. So we're going to graph this. This goes on the graph. All right, I'm going to start over because I have to transform it again. I need a reflection over the y-axis. So now are my new points. And I'm going to say rewrite. Now I have 1, 3 and -5, -4. Okay, so these are a new set of A and B. And here we go. My last move is to dig up the notes from the other day on reflection, boy, and find the rule for reflecting over the y-axis. Here it is. If AB is reflected in the y-axis, then its image is the point -AB. Okay, that's why I rewrote it, so I can go back to the other notes. You can do this slowly and methodically, and I need -AB to do my reflection. Okay, so that just changes the sign of the first. -1, 3, and from -5 to +5, -4. Graph this one. Like I said, the homework's a little shorter today so that we can focus on being methodical. Build the method we like best. Are we a visual learner? Are we a textbook learner? I've made a little list for myself. I need to graph a couple things. Okay, I'm in the textbook here. I need my points -3, 1, and I need 4, -5, over 4, down 5. There's my first. I am going to graph my rotation. I need a new point, 1, 3, and -5, -4. Huh. Okay, so took this image, rotated it 90, 180 where it would have been parallel, and 270. Okay, I can buy that. Now I'm going to reflect this second line here across the y-axis. So it's going to reflect from the left side to the right, and this point is going to end up over here somewhere. And hopefully we got our points correct. 5, -4. 5, -4. And -1, 3. -1, 3. There it is. I think I'm going to get a green check mark on this. Nice. Take your time on these. I think there's only 15 problems in the homework. These are the problems that make you smarter. When Miss Barrett and Mr. Scott and Miss Sitek and I watch you guys work, we can see you getting more intelligent. Treat these as puzzles. Good luck in your work today. Thanks for your time.